Okay, would you like to see the solution to this problem? Okay, so remember, I need your... Do I have everyone's quiz? Okay, good. So remember, a woman was just told that she tested positive for a mammogram. Okay, she tests positive, is alarmed, and wants to know from you whether she has breast cancer for certain, or what are the chances are. What are the chances that someone who's been told they tested positive actually have breast cancer? Okay, so what we know, this is what we know, that in the overall population, the prevalence of breast cancer is 1%. What do we know about mammograms? That if a woman has breast cancer, then 90% chance it'll actually catch it. That there'll be a positive test result. If the test result is, if a woman does not have breast cancer, she still will test positive at a rate of 9%. So what we're going to do is we're going to make a two-way table. Like tic-tac-toe, but we're going to draw with 3, okay? So we're going to write the test equals positive, or the test is negative. Okay? And then up here we're going to say they have breast cancer or they don't have breast cancer. Okay? And then here's going to be our totals. Okay? And what we know is we know a bunch of percentages, and we want to turn these into raw numbers to help us understand what's going on. So let's say that there are 10,000 people, or 10,000 women in this case, and 1% of them, only 1% of these people have breast cancer. This is prevalence, which means that there's 100 people. Okay? And now you could write this calculation down. It's 0.01 times 10,000, right? And you get this 100 right here. Yeah? Now, we know that 90% of these are going to get caught by the test. Okay, I'm going to just change the color real quick. Okay? So we know that 90% of these people are going to show up as positive because they actually have breast cancer. So they're going to be, this number right here is going to be, by the way, 90% means 90 out of 100. So 90% of 100 is just 90, yes. Okay, so there's 90 women who have breast cancer and test positive. That means there's 10 who have breast cancer but test negative. Now this other one right here is the 9%. The 9% is going to be of the people who do not have cancer, how many test positive? 9% of them test positive. So what number goes in here? Well, we know that this plus this has to equal that. So this number right here is really just 10,000 minus 100, which is 9,900, right? Okay, what's 9% of that? Well, that's going to be, 9% of that is 0.09 times the, and now I didn't leave myself enough room, times 9900. Does anybody remember what that number is? It's 891. And so what's left over in here? It's going to be 9,009. 009. Okay? Do you follow that? Did you agree with that? Any questions about that?
I couldn't figure it out, but you can clarify it. You always start with 10,000. I couldn't get 10,000 from where?
You could have started with a different number, and it just would have made some of these into decimals. 10,000 is just a convenient number, because what we need to do is understand how all these different percentages relate to each other, and that's what we're doing. And we need an actual number to help us do this calculation, because otherwise it's really hard. But we know 1%, if this is our total population, I could have picked the number 5 right here and done this calculation and carried lots of decimal places, and we would still get the same answer. Okay, that's a trippy thing. But for these problems, you can always just start with 10,000. It makes the numbers come out nice. So we now can add these up, right? What's 90 plus 891? What is it? 981. And then 10 plus 9,009 is going to be... Now, the thing you can do to check is add these up. 1 plus 9 is 10. Okay, good. So if you now this plus that should add up to 10,000, right? Okay, good. So if you got this far, a lot of you are like, great, I'm done. No, you haven't answered the question. What do you say to the woman? What do you tell her?
It is a 9% chance.
And how did you come to that conclusion? Because you say, really, ma'am, what we need to calculate is the conditional probability that you have breast cancer given that you've tested positive. Right? That's what we're going for. So remember, the whole thing about this is basically of everyone who actually tests positive. That's what this conditional thing does, is it changes the denominator. We don't care about the whole population. We're talking about those who actually test positive. 981 positive tests. How many actually have cancer? 90 of them. So the odds that her risk of cancer, given that she has a positive test result, is 90 divided by 981 is 9 point. Everybody take 90 and divide it by 981. Did you do it already? Some of you didn't. I believe it's 9.2. 0.0917, right? Yeah. Is that what you got?
Yes.
That's fine. Yeah. But check that out. That's not 9 in 10. That's 9 in... It's more like 9 out of 100. It's closer to 1 out of a... Yeah, it's 9 out of 100. Oh, why am I saying this is 9 out of 100? That's what 9% means. Percent means per 100. Right? So this is about equal to 9 out of 100.